Okay, this recording is going to wrap up all of EnMath B, whole EnMath B, Engineering Math B course. And the subject is, this last subject is solving partial differential equation, boundary value problems, using a Fourier transform of some kind. Fourier cosine sine transform. That means, let's see. Our little pointer, there it is. These are the three transforms. It's the Fourier transform, sine transform, cosine transform. And they're corresponding what they are, because we're doing this to functions of two variables. These are what they are if you do it with respect to x, and then these are what they are if you do it with respect to take these partials with respect to the other variable. So the process was you transform every term of the partial differential equation using one of those three transforms, and also transform the boundary condition using the same transforms. That will lead to, well, the first will lead to ordinary differential equation. Simply transfer the partial differential equation, transform it, that will lead to an ordinary differential equation. That along usually with one of the boundary conditions. And from there, you use algebra, another boundary condition, which gives you a transform of the solution, and then you inverse transform it. Somewhere we have inverse transform. Here's the formulas for inverse transform. You've already done a bunch of examples of that, on 5 or more. I'm going to do the final 4 examples because they each have a little bit different. So here's example 6. Remember, with 3 transforms and 2 variables, you have 6 possibilities of which transform to use on which variable. That was one of the most subtle points to this whole thing, I think. Here, 2 variables are x and y. They both come in as seen in second differentials. That doesn't tell us which variable. They're both semi-infinite, so that doesn't narrow it down. So let's look at initial condition. Here's where x equals 0. You get a nice boundary condition of 0. Here, when y equals 0, you get something, but it's not a nice 0 condition. I'll say we'll do the transform with respect to x. And since we have this derivative 0, that leads to the cosine. I'll use the cosine transform with respect to x. Look up the formula sheet. That leads to this differential equation. Here's a little trick. Here's a little twist to this problem. There was 2 forms of this solution, either the Cauchy-Singe form or this form. This is now in y, right? Range of y is semi-infinite. So we use this exponential form. Here would be the solution. It says, look, we have 2 coefficients to determine, but we only have 1 remaining boundary condition. Here's the other twist. We assume the solution must be bounded. That leads us to make a equals 0 here, leaving only the b part. Then we'll use this condition to solve. I'm not going to go through all that. It's not going to go through all that. I've already done the twist in this 2 twists. Or one, it was a little bit subtle of which transform to use on which. The other twist was I use quotient singe or the exponential form like here, and then apply boundedness. That's sort of the third twist. Do another example. Here, they both show up as second derivatives, so that doesn't tell us much. But x, the range of x is finite, y is infinite. Says do the transform with respect to y. So we're looking for where y equals 0. Here it is. It's the derivative of the function. We just do again the cosine transform with respect to y. Do that. It's to this ordinary differential equation. Looks like the same as the previous problem, but in this case, equation in terms of x, and x has a finite, so we use the quotient singe format. Here, boundedness doesn't come into play, but at least we have two different boundary conditions for each of the two coefficients to be. And here's kind of the twist to this one. We're going to get some, when you plug in the other boundary conditions, yes, you can solve for A and B, but it leads to something messy here. And we can use a hyperbolic trig identity to simplify that a little bit. There. Still looks a little ugly, but this is more elegant or simplified than this. That's the twist to this one. Just a little bit more extra algebra in solving for the A and B here, and then using a trig identity, hyperbolic trig identity to simplify it. I think the last two examples are pretty much more of the same. Here again, whoops, here again, what do we have? They both show up as second derivatives, so that doesn't tell us anything. X is finite, y is semi-infinite, so do it with respect to y. We're looking for where y equals 0. Here it's on the function itself, so we'll use the sine transform. We're also going to need a little bit different differential equation because here's what we get. This ordinary differential equation, that's not quite something at least I had on the formula sheet, so I put it in the, here's the solution to this type of equation. There's our solution, and again we have to solve for two coefficients. The algebra gets a little bit ugly. Here's the result of all that. Solve for A and B, plugging in the boundary conditions, doing the algebra. Something pretty ugly. But again, we can use trig identities to simplify a bit. Call this a simplification. That's the twist in this one. It's just a bit of ugly algebra and call it trig identity. One last example, I believe. Oops, let's do this one. Let's see here. Both second derivatives, that doesn't narrow it down. X is semi-infinite, y is finite, so we're going to do it with respect to x. Either the sine or cosine, right? Because it's semi-infinite. Let's look for where x equals 0. With the function itself, so we'll use the sine transform with respect to x. You can do that. Differential equation. We have a canned solution for that, the good old quotient singe. This is in y, and y is finite, so we use quotient singe on the exponential form. Remaining two boundary conditions to solve for A and B. That leads to this. The algebra gets a little tedious, and again, we can use the trig identity to simplify a bit. There it is, invert the result, and there's your answer. So those last three examples were kind of more of the same. They were a little bit more algebra intensive, and you could simplify things by hyperbolic trig. And that, boys and girls, End of Engineering Math B, the whole course. So I guess my next project is Engineering Math A. And if you want any more material on all this stuff, I have it all typed up in notes, have the charts I use. Email me. I think somewhere in these videos I have my email address. Bye, kids.